Hello, my name is Derek Thomas and I'm the Director of Educational Research Techniques. In this video, we are going to deal with the special angle of the 30, 60, 90 triangle in relation to the unit circle. So let's go ahead and get started. Alright, so you can see here I already have my unit circle set up, and of course it's not drawn to scale because we drew it by hand. And I'm going to first draw my 30, 60, 90 triangle here. So when we do that, we have kind of the following shape, something kind of like this. Oh, whoops, that's not quite right. And then we go down like this, and of course this is the initial side right here. This is the terminal side, and we drew it in standard position. And so we're going to have our coordinate now here, x, y. This is what we want to figure out. Where on the unit circle are these coordinates right here? And there's lots of other information we have. If we know this is a 30, 60, 90 triangle, that means that this angle is probably going to be, this is going to be 30 degrees, this guy's going to be 90 degrees, and this guy up here is going to be 60 degrees, like so. Now, just for our record-keeping purposes, this will become more important in a second, you need to know that 30 degrees is pi over 6 radians. That'll be important in a few moments, but not quite yet. Now, one thing I forgot to mention is that, of course, our radius is going to be a length of 1 because we're dealing with the unit circle in this particular situation. Now, watch what we do here. Now, this kind of surprised me when I first learned this myself, but it does make sense if you give it a moment to kind of think about it. The first thing that is very commonly done here is that you draw a second triangle. Now, again, this is not drawn to scale because we're just not good at drawing to scale, but this is kind of what it should look like, something like this. And now you have the same angles here that you have in the other triangle. So this is going to be 30 degrees. This is going to be 90, and this is going to be 60. But now the beautiful thing is that if you take the whole thing, the whole entire thing, you now have an equilateral triangle. In other words, the sides are the same length and the angles are the same length for all three sides, all three angles. Now, watch what's happening here. Try to make this as clear as possible. So you know that this length is y right here, from here to here. This is length y because that's the y coordinate. And this is also going to be length y. Now, if the radius equals 1, right? So the radius equals 1, and we have two y's, that means the radius can also equal 2y. I mean, hopefully you can see that. You can clearly see we have two y's here, and we know that this distance is 1 because we just created an equilateral triangle. So if we solve this r equals 2y algebraically, in other words, we want to isolate the y, you divide both sides by 2, divide both sides by 2, and you can say that, to keep this as simple as possible, that 1/2 r equals y. This is very, very valuable. All right, now check out what we're going to do here. We're first going to find the y coordinate. So to do that, we need sine. Okay, so we need sine. We're going to use the sine function first. And so sine, we're going to use radians. Sine pi over 6 is going to equal, now what does y equal in this case? Well, we know what y equals. Y equals 1/2 r. So 1/2 r, we know what y is. Now we also know that r, it equals 1. So we really don't need the r at all, if you could just say 1/2. And so you can see now, we already know the coordinates for y is 1/2. Very, very clearly seen. I hope that you can see the process that we use to deal with this. So let's move on now and deal with cosine for a second. All right, this is what we need to do. We're going to use the Pythagorean identity to figure out what cosine is. So watch very, very carefully what's happening here. This is what we know. We know cosine squared, pi over 6. Why are we using pi over 6? Because even though we're looking for the x coordinate, it's the same angle, it's the same degrees. And so we know that it's 30 degrees, and so therefore we know that we can convert that to pi over 6. Now we're going to do plus. Now we already know what sine pi of 6 is. Remember, we found that out right here. It's 1/2. So I'm not going to put in 1/2. I'm not going to put in sine squared pi of 6. There's no point. Instead, I'm just going to put in 1/2 squared because I already know what the answer is for that. I already know what sine pi over 6 is. It's 1/2. So when I finish it off, now I know that all this is going to equal 1 because we're dealing with the unit circle, and that's what the radius is. So what do I do next? I square. So I square this. So 1/2 squared is going to be 1/4 equals 1. and I still have cosine squared pi over 6. Now I subtract 1/4 from both sides. This should not be surprising. We're just trying to isolate the cosine square, cosine pi square, however you want to say it. So now I'm left with the following. I'm left with cosine squared pi over 6 equals 3 over 4. Now, I need to get rid of the square sign. So what do? I square root both sides. And so I'm left with, put a little space right here. I'm left with, oh dear. I'm left with cosine equals, cosine pi over 6. That's going to be the same as the square root of 3 over the square root of 4 is going to become 2. And so now I know both angles. I know the x angle and I know the y angle. So going back to my original slide, I know that, let's see here. I know that y is going to be 1/2, and I know that my x is going to be square root of 3 over 2, like so. That's what it is. Now we can confirm this by plugging this into the calculator. So if I bring in my calculator here, now this first one is where I do cosine pi over 6 raised to the second power plus sine pi over 6 raised to the second power, and you can see I get 1. You can see that. Now for the second one right here, this is where I put in the actual xy coordinates. So in this one I have cosine with square root of 3 divided by 2 raised to the second power plus sine 1 divided by 2 raised to the second power. And you can see when I put this in, I almost get 1. You can see there's a little bit of rounding here, but it's 0.9998477. Very, 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 very close to 1. Essentially the same thing. And so you can see here that we were able to, get our answer using either pi over 6 or using the square root of 2 and 1/2. And so we are, confident that, we found the right answer. So let me see if I can kind of shrink this down and summarize it for you so we can conclude the video. Now, in this video, we looked at how to deal with the special angle of 30, 60, 90. And so when you're dealing with that, the first thing that you want to do is after you have your triangle is you draw a second triangle on the bottom side here. And so by doing that, you now have an equilateral triangle. And with that knowledge, you can figure out what y is, because now you have the two y's, and the two y's together make up the radius. Is fairly brilliant. And so when you know that, when you figure out sine using that system, you can then figure out how to deal with cosine, which is basic algebra. You take what you know about sine, you square it, you subtract that, and then you're able to get the actual answer. Now, once you have that, you will then know your x and y. But one thing I forgot to mention, I got kind of sloppy here, is that this should be plus or minus square root of 3 over 2. And so to figure out which one to use, you have to think about what quadrant is my original, xy coordinates in. And so for us, it was in quadrant 1, which means both values are positive. So it's positive square root of 3 over 2, and then 1 over 2, both positive numbers. And that's how you do that. So my name is Darren Thomas. I am the Director of Educational Research Techniques. I hope this video was useful. Take care.